Hi everyone, today we start chapter 9. And in our first section of chapter 9, we will be talking about squares and square roots. So squared numbers and what a square root is. So the first thing that we're going to look at is what is a square? All right, so think to yourself, what do I know about squares? Well, I know that a square is the same on both the length and the height. I also know that it is one-dimensional. It's not a cube, which is three-dimensional, right? So I have two dimensions. I have a width and I have a length, or a length and a width, right? So I have two and they're equal. This side is equal to this side. I can use them to find the area of the square. Okay, so that's what I know about squares so far. But what we want to know is square roots. And what does that actually have to do with squared numbers? Well, we know that from our definition that a square root is a number times a number to get a squared number. So a square root is when you are able to figure out which number created that perfect square. So what does that mean? Well, it means that if I had x squared, so whatever x could be, it would equal p, or two of the same numbers. Okay, so it equals some solution that is p. So that means that x times x gives us x squared. Okay, so when we have the square root of a number, we're actually looking at what made up that x squared. So every positive number is made up of a negative and a positive. Okay, so it's a negative and a positive. So for example, if I had a squared number, let's look at a square here. Let's say that, let's say I had x squared. It could be made by x times x, where both of those are positive x's. X squared could also be made by a negative x times a negative x, because we know a negative times a negative would give us a positive. So every square root looks like that. So when we're looking for the square root, we're going to use this symbol here. Okay, so let's put some value behind this and actually see what it is that I'm talking about. Okay, so example A. So example A says that we want to find two square roots. So find the square root of 49. Okay, so we're looking for the square root of 49, and there's two of them. So if we were to take 49 and we said that something squared equals 49, we're going to think about the two numbers that we can multiply together that are the exact same, so that we make our square. We want our square that are going to equal 49. So this times this has to equal the 49 squares on the inside. So if I look at my squares, I could think that I know 7 times 7 is what gives me 49. So this would be 7 times 7, and that gives me the 49. Okay, so the square root of 49 is 7, or 7 squared. Okay, but that's not all. We know that a negative times a negative equals a positive. So negative 7 times negative 7 also equals positive 49. And so we know that negative 7 squared would give us the square root of 49. So if we wanted to draw this out, and we had a perfect square over here, and we had 7 times 7, or negative 7 times negative 7, both of those would work. That would mean that this whole thing here is 49. Okay? All right, let's think about another one. So if we had 2 squared, 2 squared would give us 4. And so the square root of 4 is 2, or negative 2. If we had 3 times 3, that would give us 9. So the square root of 9 is either 3 and negative 3. So it kind of just forms like a pattern. It's the same number. It has to be a perfect square, not a rectangle, but a perfect square. So 9 times 1 would not be a perfect square. That would be a rectangle. So that would not give us a perfect square. So let's see if we can have another example. Okay, so let's do 16. Let's look at example B, and I want to find the square roots of 16. So in this example, I happen to have a square that has 16 pieces. So how do I make 16? Well, I know that if I color 4 by 4, so 4 by 4, all of this square right here is going to be colored in. And that gives me 16 pieces. So 4 by 4 is a perfect square. So that gives me the square root right there. So 4 times 4 would give me 16, and so would negative 4 times negative 4. That also equals 16. So my answers are negative 4 and positive 4. Up here, my answers were 7 and negative 7. Both of those are the answers to 49, and both of these are the answers to the square root of 16 because they make a perfect square. All right, it's your turn real quick to do a try it. So let's go ahead and do a try it real quick. So try it. And I would like for you to please find the 2 square roots of 36. So number 1 is going to be 36. And then I would like for you to do one that is 100. Okay, so thinking about which 2 numbers can create both of these numbers. All right, go ahead and hit pause so you don't hear me solving it. Okay, well, I know that 36 is created by multiplying the same number of 6 times 6. That gives me 36. But I also know that negative 6 and negative 6 equals 36. So my answers are 6 and negative 6. Okay, 100. In order to get 100, I know it has 2 zeros here, so that's 10, right? 10 times 10. That gives me 100. So negative 10 times negative 10 also equals 100. If I were to make these both as a square, let's just do, so 1, 2, 3, 4, 5, 6. So here's 6 by 1, 2, 3, 4, 6. And then I color this in. Here is a 6 by 6 square. So that is how you get 36. Again, it makes a 6 by 6 square. If I were to make a 10 by 10 square, here is my 10 by 10 right here. I could color all of this in and it equals 100. So that's how I get that. So 6 by 6, 10 by 10. Again, they have to be a perfect square. All right, so now we're gonna just turn this page real quick and we are gonna talk about how to solve some problems that have square roots in them. Okay, so a couple of things that we want to add to our notes is that, one, we've been talking about integers, right? And that the integers are what make up that square root or that perfect square. This symbol that we've been looking at, so the symbol that's this symbol is a radical sign. Not like radical, totally tubular, right? Not that one. It's radical because it's kind of like not a real number. Okay, so radical is it's just a symbol that we're going to use. So this is radical. This is a radical sign. Okay, something else that you should probably know. We're going to use the number p on the inside of our radical sign to find the square root, because the number inside is positive. Okay, you can make your square root negative by putting the negative symbol on the outside of your square root. So we know that inside it's going to be a positive number because this times this gives us a positive no matter what. A positive, a negative and a negative, those both give us a positive sign. However, if we want a negative square root, we would put the negative sign on the outside. If we want a positive, we would just leave it like this. But if we want both, either positive or negative, we want both symbols, we're going to put both symbols on the outside of our radical sign. So this represents both positive and negative square roots. Okay, so let's go ahead and put this into action so that you can see what it is that I'm talking about. So if I had a negative sign on the outside of my 49, like this tells me, one, I want to find the square root of 49, but then I want the negative integer. Okay, so I want only the negative one. So I know that 7 times 7 equals 49, but I also know that negative 7 times negative 7 equals 49. So a negative square root, this means that my answer is going to be negative 7. So the negative square root of 49 is negative 7. So the square root is just one number, and it is the negative 7. Okay, if I wanted one, like we did in the last one, that's either positive or negative of 16, square root. I know from before when we did this example that it was 4 and negative 4. So in this one, I'm actually looking for a positive 4 and a negative 4. So they will ask you for which one they are looking for. This one, if I wanted a positive 9, because that one just means positive, this would give me 3, because 3 times 3 equals 9. Okay, so now that we've done some of that, let's talk a little bit about how to solve these problems, and like when will you even see them? So, I want to give you, so let's just do like problem A. Okay, so problem A says, evaluate the expression. I want 5 square root 36 plus 7. Okay, so when I look at this problem, I think, okay, I've got a square root sign. And it works just like the order of operations. So think order of operations. Okay, we're going to think about the order of operations when we see this symbol. It's going to work just like the parentheses. So we're going to do that part first. Okay, so we're going to evaluate what's in the square root so that we can then multiply. So we're going to evaluate the square root. So that is our very first step. Our first step is to evaluate the square root. Okay, that is our first step. So the square root of 36, because this is a positive symbol, I'm just going to use a regular 6. I'm then going to switch them to parentheses because I have evaluated that, but now I have multiplication. So now I'm going to keep going back to order of operations. So my next order of operations would be to multiply. 5 times 6 is 30, plus 7, and I get 37. So then 3 I would add, and 4 solve. Okay, so when I see this symbol here, it simply just works to tell us, hey, I need a perfect squared number. So let's do another example. Okay, let's do another example. Hopefully I have enough room here. All right, in this example, we are going to evaluate using the order of operations again, but in this problem, they have parentheses all the way around this thing. So 81 squared minus 5. Okay, so this is our, ignore that. So my first step is to go way inside the parentheses, right? And I know that the square root of 81, in order to get to 81, is just 9 times 9. So I'm going to do 9 times 9, and that gives me the square root, which is 9. Again, this was a positive, so I'm using a positive 9. I now need to square it and subtract 5. Again, I'm thinking order of operations. I know what comes next. So this means 9 times 9 minus 5, which is 81 minus 5. Why they had us to do 81 again, I have no idea. So my answer then is 76. Okay, so here in this process, first I had to look way inside those parentheses. So parentheses. And then I had to square. And then I had to subtract and solve. Just like I would have had this been any other order of operations problem. Okay, but what happens when you are given a problem that has a fraction in it? Okay, let's do one of those and then I'm going to give you a try it. All right, so in this problem, we have 1/4 plus 18 over 2, the square root of it. Woo! And our job is to add those two things together. Okay, so first we want to check out this. What? How do I even solve this thing? Okay, well we know that 18, the square root of 18 over 2, think of this as division. 18 divided by 2 is 9. So this is really saying 1 over 4 plus, this is division. 18 over 2 is 9. So we're really looking at the square root of 9. So the square root of 9 is 3. And 3 plus 1/4 is just 3 1/4. Okay, so really this just looks really challenging, but again, it's not. Okay, so it might just look really challenging, but don't freak out. Okay, so if I had a problem that was like this, the square root of 9 over 16. On this problem, I would just square each of these as 3 over 4. 3 times 3 is 9, and 4 times 4 is 16, and that is how I would get this fraction. Because this just means that 3 squared equals that. That's all that means. Okay. All right, so when it's a bigger number on top, go ahead and divide it to get your number and then go to reduce. If the smaller number is on top, then you would just, again, 3 and 3 equals 9. So 3 times 3, and this one is 4 times 4. So that's how you get those answers. Okay, let's do a try it. Let's do a try it so that you can do some evaluating. Okay, so try it number 1, I would like for you to do is 12 minus 3 times the square root of 25. And then try it number 2 is 15 minus the square root of 4 squared. Okay, go ahead and solve this problem. Hit pause so you don't hear me talking. All right, so I'm going to start in the middle of 25, and I know that 5 times 5 is 25, so that gives me that problem of 5, that answer I mean. Now I'm going to multiply, and that's 15, and 12 minus 15 gives me a negative 3. How did you do on that problem? How did you do on that one? Okay, and then the next problem. Oh, I should probably circle that. Okay, on this problem, I know that the square root of 4, it takes 2 times 2 to make 4. And then 2 squared, that one is 4. And 15 minus 4 gives me 11. So again, this symbol is just asking you to find the perfect square of these numbers. All right, go ahead and answer your essential question. How do we find perfect squares? And then put your answer or your, level of understanding out to the side. You can head on over to Google Classroom if you have any questions, or you can go and do your practice work. As always, I appreciate all of your hard work and effort, and make it a great day.